Hello, this is Whitney Otan, Geology Professor in the Department of the Earth Sciences, and I'm here today to explain to you this week's exercise in ESC 195 Natural Disasters Laboratory. Today's topic is Volcanic Hazard Assessment, and as we've previously spoken last week's exercise, basically volcanoes form in a variety of ways based on the nature of the volcanic materials and their eruptive histories. So as a result, volcanoes have a wide variety of potential hazards, and the hazards tend to be associated with volcano types and the conditions that occur during eruptions and perhaps after eruptions occur. So basically we need to look at a few things that happen with respect to volcanoes. First, lava flows occur as molten material comes out to the land surface and flows across a land surface. So high mafic, low viscosity lava will tend to flow across the surface, and its primary problem is associated with the fact that it's hot molten rock and has the capability of burning anything that's in it that it's in its path. Secondly, if we have higher viscosity materials that tend to be eruptive and explosive, we can get a different characteristics of materials. So one of the primary things that tend to happen is the production of what are called tephras, or pyroclastic materials. And pyroclastics is just a big word that deals with flying hot rocks. So basically if a material solidifies or partly solidifies as it's coming up a volcanic vent and then erupts explosively and flies through the air, that would be called a pyroclastic. Then the other things that happen with materials that go up into the air are ash. Volcanic ash is fine-grained particulates, kind of like sand and dust that can fly up into the atmosphere, very high elevations, can go all the way to the stratosphere, and then enter global weather patterns and global circulation carried by air currents. But both tephra and volcanic ash can produce significant hazards. Volcanic ash, for one, can cause problems with human respiration. It can be a health hazard. Volcanic ash is significantly heavier than snow, so a small quantity of ash landing on a structure can add a very large weight to a structure. And then also it can produce other hazards for transportation and navigation, such as clogging the intakes of jets that might happen to wander into ash clouds, and also create hazards for surface transportation. So volcanic ash and pyroclastics themselves can cause significant problems with respect to volcanic hazards. Secondly, we need to look at the nature of the volcanic gases. Various compounds can come out of volcanoes. Several of them can be toxic both to humans, to plants, and to animals. So basically there is a hazard of inhalation of toxic materials. The other thing that can happen is the sulfur particles and the nitrogen particles can react with both the air and water vapor to produce acids, produce sulfuric acid and nitric acid, and these can be corrosive and very damaging not only to people but to buildings, our infrastructure, and things of that nature. The next, and one of the more problematic hazards, is that of lahars. And lahars basically occur when loose volcanic ash becomes saturated with water, becomes unstable, and moves down the slopes of a volcano. So lahars can generate themselves either during a volcanic eruption or sometimes even after volcanic eruptions. But when volcanoes occur and produce very high elevation features, commonly they'll have snowpack on their mountainsides. So when the volcano erupts, basically the heat and the ash and the lava that's generated can melt the snowpack. That water mixes with the volcanic materials and can produce a mass movement slurry that moves down a valley and can produce catastrophic catastrophic mass movements associated with the volcanic eruption. These lahars can move down at very rapid speeds also. They typically can move approximately 80 to 100 kilometers per hour. That's 50 to 60 miles an hour. So we're looking at materials moving down slopes at approximately the speed of automobiles on the highway. As a result, that leaves very little time for preparation once a disaster of that nature is triggered and begins to move down slope. Lahars can produce tremendous flooding, can produce mud flows that can inundate villages, can destroy our roads, railroads, bridges, and things of that nature. So, in summary, volcanic hazards can be highly varied and dangerous. Basically, the problems arise at initial eruptions with pyroclastic materials, lava flows, and ash. These materials have different potentials to spread geographically. Ash can move the farthest distance from the volcanic source. Next, the volcanic gases coming out of the vent of a volcano can be very dangerous, very hazardous. It can be toxic, it can be corrosive, it can be a hazard to health, hazard to plants and animals, and a potentially cause damage to our infrastructures. And then third, lahars can produce catastrophic mass movements down watersheds on the slopes of volcanoes, and can become a combination of a mixture of ash, water, and other soil debris that's captured by the erosive potential of the flows. And these materials will run down the volcanoes and then produce deposits at very low elevations at the flanks of the volcanoes. Both the erosion in the stream systems and the deposition of this material at the low slopes can produce significant problems for built infrastructure such as our houses, our homes, etc. So with that, hopefully you'll enjoy this week's exercise, getting a chance to understand the myriad of hazards that volcanoes can produce. Hope you enjoy your exercise. Have a good day. This is Whitney Otan signing off.